back in 1 sec.
Yeah, sure. Could you sleep, Matthias, when you had your first, like on the due date? We're talking about the psychological effect of the due date. Yeah, it's kind of strange. Like we talked about that.
Was up all night, actually. So.
Yeah. And it's kind of weird because the due date is actually the least expected day during those kind of 4-week specter. It's a much higher chance that it happens before or after that date.
Well,
yeah, but it's good fun. We're a day late here, so
right. Oh, okay.
So maybe this weekend, we'll see. You doing okay?
Yeah, I'm doing okay. Do you know if it's a boy or a girl?
It's a girl.
Oh, okay.
You got any pro tips?
So congrats.
Yeah, thanks.
Well, my daughter is 16 and a half right now, so I don't know.
16 and a half. That's like, it's going okay. Isn't that like the most suspenseful period?
Yeah, so she's driving around in the car right now, trying to, starting to get her driving license.
Yeah. But you must.
Okay, so you're nervous?
It's very mixed. It's like 80% excited, 20% nervous, or 80% nervous and 20% excited. I don't know.
Yeah. Okay. It's going to go fine, I think. So
yeah.
So how it's in Norway? Do you have like is it 10 days that you have from the government that you can be home, or?
Oh.
So in Sweden you automatically get 10 days. So that you can be at home, and then you have this parent days that you can between. Yeah.
We have 2 weeks.
Okay.
Yeah, and then it's this, you can decide how much time like you have paternity leave and maternity leave, and you can decide how much each person should have. So for us, Ragne will be at home for a year, and then I will be home for 2 months.
Yeah.
That's pretty amazing. Like,
yeah, it's amazing.
It's almost like 1.5 years of paid home time with your child. But it's like they understand that it's an investment. It's so incredibly strange that they don't look at children as an investment in the country for the future. Like, being at home with your child is an important investment. Not just for the family, but for the whole country and the whole future. It's so narrow-minded to think that, oh, you just pop them out and then, yeah, it's no problem.
It costs me money.
Yeah. No, but we're lucky, Matthias, living in Scandinavia.
Yeah, absolutely.
For sure. Okay, maybe we should get started. I haven't prepared all that much, like normal, but I have some slides to lean on, and I thought I would talk to you about the startup and how we organize code and the architecture and everything. And you can just interrupt me and ask questions as we go along. You can see my screen, right? Cool. So I thought I would give you like a demo of the application first. So Ducky is this startup that visualizes CO2 emissions for companies and for people to make people realize how their lives and especially lifestyles affects the environment and what they can do to make it better. And we are currently in the middle of a project with a huge customer, so that's a lot of fun. A bit pressure, but it's really great because
the customer, which shall not be named.
Yeah. And like Trondheim has like the best professors in environmental research and all that stuff. Like they're world known for their research, and we have them right next door. So all the data we use is based on research from them. So we're building like a new climate calculator that will actually be the world's best climate calculator, because it's the latest research done here in Trondheim. So that's really, really cool. But I thought I could show you just how this works. So I can log in. That's interesting. And just 1, 2, 3. Now I'm actually saying my password out loud. That's great. Anyways, this is just me running the project locally. And there's lots of features here, but I thought I could just show you some of it. For example, on the top right here, I prepared a notification. And it's a company that wants me like registered into their company. And I can approve that on the notification. And now I'm kind of like part of that company. So when I move over to challenges, we can see that there's a challenge here that I can join. And if I join that, I can join a team. So I either join Taco Friday or Pizza Friday. I'm a Taco Friday guy, so I'll join that team. And then it opens up the challenge. And this is where all this visualization stuff happens. So kind of like the idea here is that if I go to this log here, the challenges will have different kinds of activities that people do. And they will see, like, over the duration of the challenge, they can see how much they have logged, how much their team has logged, and like all the progression. And there will be like a total goal for the whole challenge and all this stuff. And if I log something here, you kind of like see the numbers change and all that. But what's really cool is that it's real time. So if anyone logs, it just updates real time. And that's really cool. So we're
was that core to the product from the beginning, that it be real time, or?
Yeah, like this project has been built over 2 years, but it's been quite bit of a messy process because of the startup and people leaving and coming and leaving and coming. So they've been through like Alt.js with React. I think I know they started with Backbone, and then they changed to React with Alt.js. And then we just built everything up from scratch during this summer. And then we decided we wanted to be real time because it's an important feature to engage people. So that when they're kind of like look at the challenge, they will see that everybody's kind of constantly contributing, which is really cool. And then there are like leaderboards and stuff like that. And then leaderboards are surprisingly hard to do, especially our leaderboards, because it's based on your position in the leaderboard. We fetch different kinds of people and stuff like that. But anyways, I don't want to spend too much time on this. But this is basically what we're doing. We're building this platform for companies to engage their customers and ultimately change their lifestyle to reduce CO2 emissions. Yeah, cool. So the question is, how do we build this project? And this is kind of like the architecture. We have on the bottom right there, on the client side, we have one repo called Ducky Components. So we have one repo for components, and then we have a different repo, which we call Ducky Web. And then we'll, of course, have Firebase on the server. And we also have something called Ducky Service, which is also contained in the same repo as Ducky Web. So what I thought I would do is just go into each of these different parts of the architecture, and then you kind of like will see how all these communicate and how it works. Cool. So Ducky Components is a separate repo. It's actually open source, and it's based on React. So there's no business logic at all inside that project. It's only about components. And the way we do this is that we have this really great designer called Arne, as Brian says.
Yeah, Arne.
Yeah, Arne. He creates these issues for us. So I wrote this article about, what did I call it? Like industrial design meets React or something. And he has he doesn't only design mocks, he actually creates a recipe for us. So for example, if I click one of the issues here, we can see how he defines something we are going to build either in the core project or usually in this Ducky Components project. So what we see here is the mock on the left, and then we have the composition on the right. So he creates these composition mocks, which tells us what other components composes this mock, or this view, or this visualization for the customer or the user. And then he use his words to explain to us what this is and how it's going to work. And of course, we also communicate daily about this, but we have it all in an issue. And then he actually lists up all the CSS properties for us. So he does not implement anything, but he wants to understand how we work and how his design choices affects the implementation. So he knows quite a bit of CSS. And sometimes he even creates a JS bin for us, for example, showing us how the component looks in pure HTML and CSS. So we have, does anyone have, Alexi, could you turn off the microphone? Thanks. No worries. Yeah, so he lists up all the properties and stuff and gives us examples. And we try to talk about mocks are usually the best presentation of state. For example, this bar chart here, how does that actually look when there's no data there? Usually you get a mock with the perfect sized bars. How does it look if one bar has a lot of more in its value than another bar and stuff like that? And we have talked a lot about this, and he's really good at trying to explain different states of the component as well. Yeah, and here we see different states. You have not joined, you have joined, your team is leader, and all this stuff. And then he actually links to the other issues of the components that is composed into this component. So all these components up here.
I would never guess he was this organized.
Yeah. Yeah, it's a real surprise. It's a real surprise. You should see his shoes. It's they look like sandals.
This is really detailed.
Yeah,
and, meticulous.
Yeah, and it's kind of funny when you see him work on his tiny laptop with the mouse on top of the laptop, next to the touchpad. He has this tiny mouse, and he works in Photoshop and Illustrator and all this.
Yeah, and he has 100 files on his desktop.
Yeah.
I'm making that up, but
yeah.
I could imagine.
Yeah, you can imagine. But yeah, so he links to the other issues. So usually when we get an issue, these checkboxes aren't checked because we haven't built the core components yet. So we can just click along, and then we build it up as we go. Yeah, so the way this project works right now, we're in a transition. So we have our own preview site of all the components. So maybe I can jump into some code there first. So this is the Ducky Components project. And in the source folder here, we have all the different components. There's quite a lot of them. And as I said, we had like our own preview page. But then we found this storybook project, which actually fits like a glove to our project structure. And storybook looks like this.
So that was like the first thing I thought of, actually, because he makes those mocks in Photoshop of the various states.
Mm-hmm.
But like with Storybook, you can use like somewhat real data to create those states of the components instead of statically in Photoshop.
Exactly.
Yeah.
That's very true. And Storybook, like our experience, it's just amazing. And one thing is the visualization. As you can see here, we have the different components, and we define the different states. But you can kind of like search them and all this stuff. But the really cool thing is, for example, if we go to knobs down here, we can actually change values, and we can see how that affects the...
Yeah, that's really cool.
Yeah, so it's not only that we have different states, preset states, you can also customize.
Interact with it.
Yeah. And the way this works, and this is what I really like about it, the way this works is that you have, let's see, action button, for example. You actually define these stories, as they call them, with the component. So previously, when we had our preview window, we kind of like defined everything there. But now we actually define the stories with the component. So for example, this action button is kind of weird syntax, but it kind of makes sense, I suppose. You have, what's this module thing? Yeah, no idea. Maybe that's a bad example. Let's look at bar chart. There we also have module. What's that? Okay. I have no idea what this module is. Oh yeah,
move along.
It's of course module exports. So it uses module exports to probably export all these adding of stuff to handle hot reloading and all these kind of things, I suppose. Anyways, move along. So we can define a story, and then we can add, these are kind of like the different states. So we just put in the component and what state it should be in, and then it just works. And when we change it, there's like hot reloading. Is there like, do I have small here? Small. Did it change? Large, standard? Oh, yeah, I don't remember this. But anyways, it's hot reloading. So that's really nice. And this is what I also like about separating the project, because components only using React, no problem whatsoever with hot reloading. It's perfect for that. But if you do hot reloading in your application with business logic, you usually have to refresh, because you're like, well, at least when you're working on your business logic. So that's really, really cool. Yeah. I don't think there's any. Are there any questions related to like this stuff?
No, it's really cool, and it's awesome that you have a designer that works the way Arne does, because like I don't know if you could do this with everyone, like he's so like sometimes people are just like, oh, I just want to throw something up there and see if it works, whereas like this takes a little more thinking about all the individual components and communication and all that.
Yeah. And this is, that's very true. And this is actually partly the reason I started helping the startup, is because of Arne, because the way he works and how insane amounts of work goes into understanding how his designs actually affects the implementation. And yeah, as you saw the issues, he's like a savant when it comes to this. But I think it's super inspirational. I worked in many other teams with many, well, not like a huge amount of designers, but some, and I've never worked like this before. And it's freaking amazing. That's for sure. Cool. So that is like the components project. And then we have the main project, the application itself with all the business logic. And that's a different repo. And it's, of course, also based on React, but it's also based on Cerebral because we need to handle all the business logic. So Ducky Components is a dependency to Ducky Web. And that's where all the fun stuff happens. So, for example, if I can refresh here now, and we can take a look at all the stuff that's happening inside the with Cerebral. So basically, there's with Firebase, it's like there's this article saying that if you use Firebase, you get a lot of spaghetti code. And yeah, you do that if you don't manage it, because you do so much fetching. You don't have queries for stuff. It's like the opposite of GraphQL. You can't like say, okay, I want all this data and then request it and then get everything. You have to do lots of requests, but that's just how it works. But it's real time. That's a benefit. And also the way you structure the data is very similar to how you would structure it in the client. And I'll show you that later. But as you can see, for example, when we went to the feed here with the feed router.
We don't see your screen right now, Christian.
Oh, you don't? Oh, what happened? Thanks for letting me know. Oh, sorry. Oops. Screen sharing. There we are. You see it now?
Yeah.
Great. Okay. So yeah, in the debugger here, we see that a few signals fired. Some of it is related to user agent because I opened it and changed the size of the window here. But feed routed is like the initial signal. And since that's like the first time you go to the route, it needs to authenticate the user. So here we can see that it checks if you have the user. And if not, it needs to grab the user. And we can see that, okay, here we get the user from Firebase. And then we set the user. We also need to grab the profile of the user. That's two different things in this world of the Ducky Web. And there's so many things happening. We need to insert the profile. We need to check for new notifications. We have to figure out what data is missing. So for example, if we have a notification related to a company, we have to grab that company as well, which is happening here. And we have to listen for new notifications. We have to listen for the notification count. And all this stuff is happening. And that's why I understand why it can easily be spaghetti code. But that's really cool. Like it seems like Cerebral is a really good fit for Firebase, and that's basically because it handles lots and lots of complexity. So it has been like invaluable just to have this tool, especially for the developers who aren't like senior developers. Like we have been able to onboard a new developer very, very easily, like in a matter of a few days. Because they understand at least how it works. And it's just easier to make changes when you understand.
What a concept.
What a concept.
Developers understanding how the application works.
But that's like, and it's kind of a good point. It's when you see an application for the first time, like as a new developer, you have no idea what's happening. And the stuff you see down here, this is not Cerebral complexity. This stuff has to happen for the application to run. Like we have to check for new notifications. We have to download the profile. We have to listen for new notifications and all this stuff. So it's just
the best you can hope for is to stick it in some corner of the code base and you don't have to change it.
Yeah. Yeah.
So you don't need to, so you don't need to think about it.
Yeah, exactly. and then something bad happens, or you need to change it, and then nobody, well, like especially new people don't understand how it works, or what it will affect.
Yeah.
Yeah, but as you can see, when we go to, for example, getting profiles, getting challenges, that's not so complex. But when we open a challenge, a lot of stuff is happening. We have to get the challenge details based on the user, like when did they join and what team are they part of. We have to get the activities that we can log here. We have to get the daily stats of the user. We have to get all the team scores, and all this stuff. And it's really, really cool to see that also the debugger can handle all this stuff. It's like insanely lots of stuff happening, but we never experienced any problems with the debugger in terms of handling all this complexity and visualizing it. So that's really cool.
Really cool.
So yeah, and as you can see, like we have lots and lots of state here, but we have namespaced it, so it's really no problem for us to handle it. So that's how it looks. And if we can jump into some code, let's look at, maybe we can take a look at some signal here. Let's see. Okay, so let's see how it's structured first. So we have like the client folder, and it has a modules folder and a components folder. What's kind of interesting about the components folder is that we have both a desktop and a mobile folder. So we actually lazy load the correct version of the application because it differs so much in the components, how the application looks.
Did you win your fight against the responsive web design?
Huh?
Your hatred for responsive web design looks like you prevailed.
Yeah, because now I made all the decisions.
Yeah, that's
but the thing is, like, it's not only it looks different, it also acts different, and that's the main argument for splitting it up. It's because it actually, the functionality is different on mobile than on desktop. But it's really cool how this lazy loading works. And yeah, so we also have like the modules here, and we have just split them up in, we are not actually using submodules. We will probably do that some more because things are growing, and it's actually a wise thing to be a bit ahead on organizing, so you don't organize like for a very small application when you know it's going to be big. So that's just an experience from us. But let's see at, for example, challenge. We have some signals there. And we can see like whatever is happening when you click the bar chart, we change the currently selected team. When it mounts, we do lots of different things. So and some people call this like the pyramid of doom. And I can understand that when it's only related to error handling. But it's not only related to error handling. It's related to checking different things, like different states in the state store and all this stuff. And also like to be able to visualize it like we do in the debugger, it kind of has to work this way. So you could write it with less code. You could like throw an error and then just generally throw that error and show some message to the user. But that would be harder to visualize how everything is connected and dependent on each other. So yeah, but this is how our signals look. It's pretty much like the documentation, really. We compose in different chains, as we can see here, and we run them in parallel, and all this good stuff. Yeah, and our actions, we have lots of actions here. So this is typically where we should refactor to submodules. But our actions are typical actions. We talk to a Firebase service. We grab the output. or sorry, we grab the result and create an output to the signal, and all this good stuff. So it's pretty organized now. It could be even better, but of course it can always be better.
Yeah, it looks pretty good to me.
Yeah, and as I said, like if you want to change something, like in the challenge here, like something else should happen between getting the teams and getting the challenge, for example. It's very easy to just understand, like, okay, should this happen before we do this or after this? And you kind of like just put in an action or a chain, and then it will just work itself out. And it, yeah, and there's not so many decisions up to the developer. Like this has a very set structure. So it also, again, related to bringing in new team members. If you code this in vanilla JS, you can of course do that using promises and everything, but there's too much up to your experience and how you want to code. But this gives you like a convention for defining all this complexity, which is also an important point, I think. Cool. I don't know. I don't want to spend too much time on stuff. Are there any like questions or related to that?
Do you use the Firebase module, Cerebral, or is it?
Yeah.
Yeah. Okay.
Yeah, and it has everything from authentication handling, and there's so many strange things in Firebase, in the Firebase client. Like when you log in with Facebook, you log in with Facebook and you get redirected, and you have to like do a second type of call to Firebase to figure out if you were redirected. And even just grabbing values, it's like it's an event listener. So you can imagine like grabbing values, instead of using a promise, you have an event, and it's kind of messy in my experience. And I think also that is why Firebase is getting some critique. It's because it's difficult to do simple things. So the Firebase module just wraps everything around promises. So you have like a normal API, and you always get the promise, and it handles everything related to redirect and all this stuff. So it's a more like intuitive API, at least in my opinion. It's a lot more intuitive, and it fits very well with Cerebral and the way it expresses these complexities.
So what were your decisions around using Firebase instead of rolling your own like WebSocket server?
It was basically because we did not have like a bunch of senior developers. That was one thing. So Firebase makes it incredibly much easier for like junior developers to take ownership in that part of the stack. But also like time constraints. We needed real-time functionality, and we would spend a lot of time implementing it, because it's not only real-time. You have authentication and all this stuff as well. And like figuring out the best way to structure the data is also one thing. And Firebase just forces us to think in a certain way, which can be challenging, but at least we know when it's wrong, because we can't make it fit with Firebase and its structure. So we kind of like, we know when we're right about something, because then it's kind of like obvious how it should work. Well, I think that's more difficult to do when you have more freedom, if that makes sense.
Yeah, cool.
Awesome. Okay, so then we have Firebase. So Ducky Web talks directly to Firebase. There's no custom backend between the client and Firebase. There's like a direct connection. And what the client does is that it grabs data from Firebase, and whenever it wants to change something, it sends a task to Firebase. And I'll come back to that later. But I thought I could show you the Firebase console. Oops, sorry. Let's have a look here.
So
Okay.
is this almost like the Meteor dream realized? You remember Meteor,
yeah.
where it was like you had mini Mongo on the
Yeah.
client, which had the same API as MongoDB, and it was like in your client JS code, if you inserted a record to the mini Mongo, it would automatically, replicate to the server side one. So it was almost as if you were just inserting in the database, like right from the client.
Exactly.
Same kind of deal.
Yeah, same kind of deal. Though, yeah, just a different API. And yeah, like Meteor is the whole stack. So with Firebase is like only the backend kind of. So you choose your stack in the front end.
Yeah, but that's what I'm saying. It's kind of like the Meteor dream realized.
Yeah, definitely. Cool. Yeah. So the way this works is that, and what you might notice right away is that this is structured much like a single state tree, because it actually really is. And you have all the same kinds of types you have in JavaScript. So for example, in transport here, you have like numbers, you have strings, you have booleans. The only thing you don't have, like thinking JavaScript, is arrays, which might sound incredibly weird, but it's actually not a problem at all. So what we do is that the structure inside Firebase is kept when we move the data to the client. Let's see if I have an example of that here. So for example, in app, yeah. So here we can see that I have been downloading some profiles. And it's not an array of profiles, it's a map. And it looks exactly like it does in Firebase. And that just makes it easier for, again, like I want it to be simple. So you don't have to be like a crazy badass developer to work on this. And just using the same data structure in the client as in Firebase just makes it's less of a mental load, really. So what I've realized is that maps are really good for storing data related to entities when you have like an ID. Because if you do that, then it's very easy to look up the data. You just need the ID or the key or to grab the data. You don't have to iterate anything to find something. But the components, when you're going to display data, that part of the application loves arrays. Like you're going to create a list of components and stuff like that. And that is where like computed comes in. It's kind of like, okay, you keep, related to Firebase, you keep the data inside Cerebral as similar to Firebase as possible. And then you use a computed to convert that data structure to something the components like, typically an array. Yeah, typically an array.
Yeah. I think that it makes sense that Firebase doesn't have arrays, because then you wouldn't have, you couldn't listen to just one. Like
that's
listen to them all.
Yeah, that's a very good point.
So is the expectation that you fetch all these separate entities and then you combine them, like the relationships on the client?
Yes.
Okay.
Yes. Yeah, we're forced.
So now I know. Now I understand why you called it the opposite of GraphQL.
Yeah, exactly.
Because GraphQL is like you say exactly what you want in the shape that you want, and it gives you exactly that.
Yeah, exactly. And also, like, just arrays are like, the good thing about an array is that you can have the same thing in the array multiple times, while in a map you can't have that. So so it kind of makes sense when you have entities with unique IDs that you use.
Yeah.
Because
it makes sense because it's one end of the spec. Like a lot of times, I think we all spend like we have to deal with the worst of both worlds in the middle with a traditional REST API, where it's like you kind of get it in the shape that you want, but some stuff is embedded and it might get out of sync. So then you need to convert that to like IDs.
Yeah.
You know, so like it's like half and half. So it's like kind of giving you the stuff in the ship you want, like GraphQL, but then you also have to do the stuff you need to do with Firebase and like separate it by ID and then join it together on the client. So I could see the value of like either the Firebase way or the GraphQL way, but most of us get stuck with the worst in the middle.
In the middle. Yeah, that's a really.
Like I still need to munge this data, but
yeah.
kind of sometimes. Like
yeah, that's a really good point, and it's really cool with GraphQL that you kind of like you bypass, in this case, you bypass Cerebral, you bypass computed, and you just get exactly what you want in the components. The problem though is that what about everything else? As we talked about earlier, when you want to change the state of your like client-side state of the application as part of the flow of fetching something from GraphQL, or you want to listen to some data as part of fetching some data from GraphQL. It's
you're making a very good pitch for Cerebral too, though.
Yeah,
because with providers, that's a lot easier, right? Like if you have this other thing that sort of manages your entities, you can add that to the context. And if you have this thing that's more managing your UI state, you can have both.
Yeah.
Right. Because the problem before was with the with the debugger and all that stuff, but it sounds like a lot of progress has been made with that.
Word.
But I agree with you. Yeah, it is simpler just sticking everything in one state store. That's cool. But I guess I'm saying I'm excited about Cerebral 2 and function tree, how that limitation has been lifted. It's a little more flexible, so you can integrate with these other entity fetching thingies like GraphQL and Falcor and stuff like that, but you still get all the goodness for Cerebral. They can kind of work side by side.
Yeah. Word. Cool. Yeah, so basically here is all the state of the database, and we also have like authentication. We have all the users who can easily delete them and do whatever we want. We also have storage, so when we upload avatars for the users and images for the posts and stuff, everything is just inside here. And Firebase also does the hosting of the application. So you get a lot for free, which suits at least this startup's requirements. What's kind of cool is, for example, if let's see, okay, I don't have any notifications now, but if I go to like my profile here and see notifications count, I change that to 5, and then it changes to 5 in the client. So you can kind of like, you can actually see if your listeners work and all this stuff, which is kind of cool. So you
that's really cool.
Yeah, so it kind of like it becomes this, like we have the same thing here for the client state. So do we have, let's see, member count? Can I change something here? Yeah, show create profile model. Can't I change it? Oh, is this a bug? I should be able to change that. What's happening? Yeah, I think this is a bug. Let me try to refresh here. The point is that just like you can change, yeah, now I can change it. Okay, let's see if we have the app and the profiles here, and we say show create profile model to true. And then we can see the client changes, just like we change some data in Firebase, we can see it directly. And we can do the same with client state, which is really cool.
Very cool, yeah.
Yes, but that's, yeah, so this is like the Firebase part. And then we can move on to...
Really quick, is that, does Firebase run on your local machine? I remember you guys talking about this before.
Yeah, that was like a challenge. Well, not a challenge, but a question. How should that work? Now we're like 4-5 developers, and we're working against the same Firebase, so you can't run it locally. You can do it for testing, but like to handle the authentication and everything, it has to run at Google. But it actually works surprisingly well. But if someone is working on a feature that affects another person, which changes the data structure, it can become a problem. But it's like we communicate a lot at offices, so it's never really an issue. One thing that has been an issue are the rules, because you have database rules. So when you change some rules, we have to make sure that everybody updates their branch. Because if they, for some reason, deploy new rules to the Firebase, then they kind of like they're missing the part that we changed. And that affects everyone. So it has some quirks, but we talked about having each of us our own Firebase, but we decided to try having a common one first, and then see how that works, and then maybe decide later to have each of our own. But currently it has been working great. So it's just these small quirks.
Cool.
So one question, Christian, one question.
Yeah.
When you get the real-time updates, how do you handle this in, like, do you trigger a signal, or what do you do?
Good question.
Because you have this once, you have this value, and you don't want to listen to value, do you?
Well, this is the thing with Firebase. You change. It depends. Sometimes you want to know, like, for example, with notifications, you want to listen for child added. So when a child is added to notifications, but for example, the counter here, this is just a value. So then we say,
can't see your screen.
Sorry.
This is so strange. Why does it stop? Why does it stop? Okay, cool. So the counter is like a value listener, and the notifications is a child added listener. And the way we express that in code is, let's see. This is challenge app. I think I just refactored this today. So it's part of header. Listen for new notifications. So this is how it's expressed. We just say on child added, and this is the path to the notifications, and then this is the path to the signal we want to trigger whenever we get an update, and then this is the options related to that. So for example, if I make a change again now to the count of this thingy, where did it go? Profiles, list. Let's see, change it to 10, and we should see, what's happened now? What? Oh, maybe that's a bug. Let's try again. Oh, maybe it knows. Is it the wrong unseen notifications? Why is it still 5? Let's see again. 10. Okay, I don't know what happened there. As you can see here, we have a signal that triggered when we changed the count of the notification, and then we see that we get the value.
Christian, we don't see your screen right now again. So.
What's happening?
But I got the idea.
Yeah.
How you? Yeah. So cool.
Yeah. So you see it there. New notifications count received, and then it updates. Okay. Awesome. And then we have like maybe the more interesting part of the architecture, and that is the Ducky service. And this, as I said, is part of the Ducky web repo. So we have the service and the actual application in the same repo. And it's a service that runs on Node. And it uses something called Firebase Q, which it connects to Firebase with. And then it uses function tree. And And what we use it for is that if you remember that the client can push tasks into Firebase, this Ducky service grabs those tasks and handles them. And then Ducky service pushes data back into Firebase based on whatever. And then that data is pushed to the clients again. And the way this works, we can look at some code. Let's see here. We'll go to the service. And what we have here is a function tree, which looks like this. You basically instantiate it and you give it some providers. So we give it a moment provider. We don't have to do that. We just chose to do it because we change something inside moment to handle UTC dates and stuff. And then we have the Firebase provider, and then we have something called the dashboard provider. And the dashboard provider just pushes WebSocket messages to a Ducky service dashboard client. So it automatically, all function trees that run will create WebSocket messages to this dashboard, which tells the dashboard what tasks or function trees are currently running, how many of them has completed, what type are them, any data we want, we can pass to the execution, like in the dashboard, and which one of them has an error. So we kind of, I don't have the demo of that, but we kind of have this dashboard with all this information, so we can see live what's actually happening in production, which is super awesome.
This is amazing because we have the exact same dashboard provider in function tree. Yeah,
that's so cool.
Super awesome. Yeah.
So so we use function tree for what we call tasks. So we can look at a simple one here first. This is the one that when you click notifications, we want to put the current count of notifications not seen to 0. And basically this works like Cerebral because it's inspired by Cerebral. And we run an action which does a transaction on Firebase. But since this is running on function tree, we are returning a promise and all this new stuff related to function tree, which we will bring back into Cerebral. But it's basically the same thing.
Sorry, really quick. Just I've never used Firebase, so why do you use the task thing to do this?
Oh yeah, maybe I should go into that a bit more. The thing is that you can't, like, how you need to run business logic on the server, but Firebase doesn't have, like, Firebase is only data. You can give it data and you can grab data from it. So you need a concept for handling business logic.
Like, oh, I need to do ABC before I stick this data in Firebase?
Yeah, like, okay. For example here, maybe this was a bad example because setting the count
setting the count to 0 just seems like you could just do it directly.
Yeah, and that's true. So that was a really bad example. But you can imagine like joining a company.
So Brian, how we do it is like, let's say you have like 4 PDF plugins that need to create PDFs, and it's only one that should have a job. So you make a transaction in Firebase, and and you pull in the job, and then the other one is idle.
Yeah. So that seems similar to like your traditional web framework, right? Where you have a router endpoint, and then you do some stuff, and if the stuff takes a while, then you put it on a queue and have some background job to do it, so then you can return from the request and go about your business. But this is expanded a little bit because it's like Express if you had no custom logic that you could put in the router to respond to the request. So is that right? Yeah. Like anything that's custom that needs to do some stuff and then put it in the database, like most of the stuff that would be in the router of Express will be handled in tasks.
Yeah.
Yeah,
Okay.
because you only want a task. If you only want one task to be run once, then you need to use transactions, right?
Okay.
Because you don't want to create like the PDFs. You just want to create the PDF once, and you have a concurrent backend, and it receives the job, and it takes the task, and the other one you might have like 15 plugins.
Yep.
And the other one is idle. Yeah.
Yep. Okay. I see.
Yeah. But Matthias is talking about the concept of transaction. But do you wonder about like the general concept?
Yeah, that's right. Yeah.
I see specifically how it handles the concurrency problem. But yeah, I was asking more generally about what problem was the test thing. So yeah, it makes sense. It's like when you can't just stick data into Firebase directly, if you need to do other stuff that goes in the task.
Yeah, because you need access as well. Like when you join a company, you're going to update the company, but the client shouldn't be allowed to do that directly from the client, because then people could mess up everything inside the database. So
yeah. And is all that stuff like first class with Firebase, like setting those sorts of permissions and things like that?
Yes, it is.
I'm assuming that's through that dashboard thing.
Yeah.
Like the Firebase web interface, or no?
Yeah, you can do it there, or we do it locally. So you have like rules. So this tells.
Okay, so some config.
Yeah, but we do this. We have created our own thing where we have multiple files defining the top level namespaces, and then we merge it together and we upload it directly into Firebase.
Right. Yeah. And then so then this ships when you deploy to production or whatever and sets the rules.
Yeah. So what you can see here.
Lots of read trues.
Yeah. And what we do for authentication, like so that not everyone can create a task for anyone, kinda, is that we actually pass in we call it the profile key, but it's actually the user UID. So we pass the user UID on every task, and then we validate it. As you can see here, is the profile key the same as the actual authenticated UID? Then we pass the task along.
Yeah, I see.
So this is where the authentication is.
Right. Yep. I see. It's similar to like an auth header for OAuth or something. You send it with every request and it gets checked.
Yeah. Okay. So so like Matthias said, like transactions are for concurrency, and so that means that this callback here, this might be called multiple times. So you kind of like have to handle it. And there's also some caching related to this. So it might run it once, but then with a cached value, and then you produce a new value, and then it sees that, oh shit, I had a cached value. I have to grab the existing data and run it again. But then in between this, maybe someone else, like a different process, updated the value. And then it's, oh shit, we're out of sync again. I have to grab the latest value. And so it runs until it's actually able to update it. Which is nice to have out of the box. But initially, this was not very, like the docs were quite unclear on this. But it might be my experience as well, of course. But maybe we can take a look at like joining a challenge, which is like, this is kind of where I can see why, like here we actually want, whenever there's an error, we just want to throw, kind of like we want to stop. Unlike on the client, we often want to display different kind of errors depending on where things went wrong. And as I said, there are not only errors we handle different states, checking different states and all this. But this is how it looks, and it does lots of different things when you join a challenge. And also like toggling an activity, there's quite a bit of stuff happening. Yeah, but it's the same principle. But what's really cool now is that, let's see, let me try to do something. You can still see my screen. Yeah, good. I'm getting paranoid now. I'm talking without you seeing my screen. Let's see here. Can I clear? Oh, let me. Oh, then run service. I'm going to show something kind of cool. So now I've started the service. And I'm going to, for example, I'm now going to click the notifications, which will first trigger something inside Cerebral, like notification menu clicked. And we see that it runs a Firebase task, check notifications. So if I jump to the service, we can see the node debugger for function tree. So we can actually kind of jump from here. We can see that it triggered a task, and then we can see the task running. Yeah.
Yeah, I'm using this as well. This is awesome.
So it's super awesome. And just it's like we talk about understanding what happens when you. This is so simple. We click this button, and like when we talk about how to build applications, we simplify it so much. Like, okay, when you click a button, you only change one state. But as you can see here, we're actually changing a bunch of state. And if you're on mobile, we do something else than if you're not on mobile. And then we run this task, which will run some logic on the back end. And again, this is actually quite simple. But we can do.
Well, and usually we leave out the entire server.
Yeah,
part of the application.
And let's see.
Like, just get in local storage, and my demo is done.
Yeah, yeah, exactly. And if I click this log thingy here, you can see there's a bunch of stuff happening. So one thing that is kind of not annoying, but I hope to find a solution for, is that there are like limits to how much. I saw your issue, Matthias, about like using stringify with indentation. Is it called indentation? Indenting. Yeah. But then it's kind of like if you have lots of data, then you have to scroll so much. But if we do like ellipses, then we don't see all the data. So maybe it's possible.
Yeah, I understand. So
Yeah.
the indentation is, but yeah, it's fine.
Yeah,
I think, yeah.
Yeah, it's been working okay for us. But I
think I will remove the issue.
Yeah, but we might be able to do something like Webpack dashboard, where we actually output like a dashboard for this, and then you can actually click the outputs and stuff. Yeah, so I think there's things we can do here to make it even better. But it's really cool. It's working really well for us. But this is like, now we actually click something in the client and we take a look at it. But we can also have a look at our tests for this, which I'm insanely happy with. So we have our tests, and they're split into like a domain, and then they're split into unit and integration tests. Tests means like, okay, we have a state in our database. We run one of these tasks. How should the database look after that? And the way we do this, again, maybe we should look at a simple example, is that we have created our a tiny test wrapper. So what we do is we prepare some test data, and then we create a task handler test. And we just pass in, we pass in the done, because we have to tell we're using Mocha. And by the way, we changed from Node Unit to Mocha, and it's a completely different world. Like, you're handling asynchronicity, you should never test with Node Unit, at least in my experience, because it doesn't throw errors the way Mocha does. Mocha always gives you the exact problem, like where it happened. Anyways, so we pass in like to tell Mocha when it's done running the task handler test. And then we give it the initial state of the database. So here we just create the state of the database. And then we run it, giving it the task. And the task is actually just an array from the service. So if we look at check notifications, like we just export an array here. We don't call any API or anything. We just export an array. And that means that when the task is running as normal, it uses this run task function tree. But when we test it, we have our own function tree for handling that stuff. So when, for example, a function tree resolves generally, like in normal production, it tells the Firebase queue that it's done running. But in the test, it tells the test runner that it's done running. So that's really powerful with function tree, that you separate the actual running logic and what's actually running it, kind of. But anyways, I'm jumping all around here. We define the initial state of the database. We run the task with some data we pass to it, which usually comes from the client. And then we have a callback where we get the new state of the database, and we test it, and that's pretty much it. So again, if I do only here, I can see npm run test has handlers integration. And again, you see like the node debugger, it helps a lot. So we are running these check notifications, and we can see every action running, every transaction value, whatever, done to Firebase. And then we see it runs. So if I do just npm test here, we are running different unit tests, different integration tests. And it actually finishes, oops, sorry, only, oh, it should be like a bunch of tests there. Maybe, yeah, I think reply company invitation. There's an only in here. Okay, let's try again. So the point is that, yeah, as you can see here, it's running everything, and we have a failing test. Anyways, the point is that testing these like integration tests are really hard to do with Firebase. But with the setup we're using here, where we have Firebase test project, which runs a local Firebase, and then we have this small wrapper around our tests, it's super simple to write our tests. So that's pretty awesome.
Yeah, that's really cool.
Yeah, and we could never have done this. Like I've been in situations where you implement.
Well, I saw your code before you used function tree.
Yeah.
I think you pasted into Discord the promise code.
Yeah.
It was like really crazy.
Yeah, and that was probably not like that code could have been better, of course. But that's the problem. Like it was, as I said earlier, like I implemented that in normal JavaScript. And
yeah, it's like that's the path you get led down when you just do within that system what is simple or easy to do.
Yeah.
Like that's the result. Whereas like in this system, if you do what's simple or easy to do, this is the result, which is much better. And that's key. Like you can't evaluate just based off of like some hypothetical, like how smart you think you're going to be in the future, you know?
Yeah.
It's like you need to optimize for like what is you on an average day and everyone else on an average day. What are you going to write?
Yeah, exactly. It's
Christian?
Yeah.
Can you go back to the Ducky website?
Yeah.
Could you explain behaglig kroppsvask for Brian? Behaglig kroppsvask.
Yeah, it's like comfortable body wash.
Ooh.
Yeah.
I like that.
Yeah, I know you like that.
I gotta get in on this. I will definitely win the comfortable body wash
competition.
Yes, I'm an expert.
Yeah, no, these are just some dummy actions.
Oh,
It's not dumb to me. It's serious business.
Yeah, but we're talking a lot about this. How do we like not make this silly and not provocative? Like meat eaters, for example, they would be super provoked if they see vegetarian dinner, for example. Like, I'm never going to eat a vegetarian dinner. But instead of saying,
but the programmer won't have a strömfri kväll either. So
yeah, electricity free, yeah, night. That's true. Well, you could use the batteries, though. You probably need your router, like for internet connection. Though you could use your mobile. Yeah, I think it's possible. Or you might have like one evening free. No, that's not possible. Yeah.
No, can't do that. Boo.
Yeah. Yeah, but my point with like
Let me
vegetarian,
just sit here and read a book like an animal.
like an animal. Oh yeah, yeah. But this is like, it's very hard to make people do things, but it's not really about doing it. It's about understanding that we are in serious shit as a planet, and we have to do something. And it's much more important that everybody tries to adjust their lifestyle a bit. And instead of everybody becoming vegetarians, everybody could just reduce the amount of meat they eat during a week with 1 day. Like, just reduce meat eating by 1 day, and then it has a huge effect. If a lot of people do it, of course. But that's the difficult part. You have all the numbers, like the climate numbers, and all these professors analyzing and everything, and then we have to translate that into something that's not silly and naive, but actually can inspire people to change the way they live their lives. It's ambitious, but yeah, getting off track here. Cool. So I thought I would just mention how we deploy as well. And basically what we do is that we have our Heroku instance where the Ducky service runs, and it's connected to the repo with the application itself and the service, which has a dependency to the component, so that it's also included. And what happens on Heroku is that Heroku actually builds the client using Webpack, and then it runs the service, which handles all the tasks, and it also exposes the dashboard. So we go to Heroku when we want to look at the dashboard. And then it actually pushes the build files to Firebase. So it pushes them to the hosting part of Firebase, and it pushes the new rules, and it pushes the what's called specs, which are like the definition for the tasks. And then it works. So like, and this happens automatically. So whenever we merge into our test branch, it will actually just do this and redeploy it, which is pretty cool. And then on our Slack channel, the others get notifications about, okay, this is the latest commit with some details, and then they can see when Heroku actually has started running the new version of the application, which is really cool. Awesome. Yeah, I'm done.
Yeah, that was very cool.
Yeah, I'm really happy about especially the situation with like the people perspective of this. Like, we aren't a bunch of senior developers, but everybody works on the whole stack. Everybody talks about how to structure data in Firebase because it's so visual. And everybody works in Ducky service, and we implement by using function tree and these tests. And we do the same approach as we do in Cerebral, where we kind of like, we define the signal first, but we don't implement any actions. We just, okay, this is how it needs to run. Like, these should run at the same time. We should call the action this and not that, and all this stuff. And then, of course, everybody works in the main project, and everybody works in the components project. So that is how also new people come into the project. They're always part of all the discussions, but they usually start implementing in just Ducky components because that's the simplest and easiest to learn. And then they kind of like move into Cerebral world, and then they move into Node world with function tree, and which is not that different really. Yeah, so
and everyone is just in Christian heaven, Christian Alphony heaven.
Yeah,
got trees on the client, got trees on the server.
It's all about the trees.
All about the trees. Everyone's in the jungle.
Yeah, but it's kind of like a tree. It's like a really good representation of data and flow, and like trees are great. I love trees.
Yeah. If only all data could be trees as well.
Yeah.
But they're not, and that's what makes everything hard.
But I wanted to mention before I forget, like if anyone's seeing this after we're done here as well, and has the possibility to work with us on React and Cerebral and what I showed you on the server side here, we have insane amounts of functionality that is going to be implemented into this. And we are like at the edge of Cerebral because, yeah, I'm one of the core contributors. So yeah, if you have the possibility to join us, we should definitely talk. It's an awesome project and it's a lot of fun to write the code. So yeah, just had to say that. Cool. Yeah, I guess that's enough for that part. I don't know if we, I haven't really prepared anything related to Cerebral 2. It's just going really well. I'm currently working on, I'm going to work on freezing objects and arrays in development mode. Because as we talked about when we released Cerebral 1.0, is that we wanted immutability by default because we wanted people not to mutate where they shouldn't mutate. But we don't need immutability for that. We can use the freezing approach. Yeah, because now we don't need immutability to get the features we want out of Cerebral, not for updating views and not for do time travel debugging, recording, or whatever. So that's really cool. So it's going to be super exciting to start trying this stuff out. And we will, of course, refactor our project into Cerebral 2 as soon as possible. Alexei is working on the build steps of the project so that you guys can actually install it from NPM and test it. So he said he was going to work on it this weekend. So hopefully during next week at least, we will have an NPM install for you and you can try it out.
Yeah, I would love to get some commits in and help move it forward too. I'm just a little scattered right now, so I kind of need like someone to come along and say, Brian, do this, and this, you know, and then I'll find time for it.
Yeah, and that's exactly like Cerebral 1 was about wrapping up all the stuff that has been done and discussed for 2 years. And Cerebral 2 is all about simplifying that, like taking the next step and also making it possible to contribute because the code base hasn't really been that good. But maybe I can just quickly show, as we're talking about it, I can quickly show the code. Oops, what's happened? Oh, there we are. Okay, so we're moving a lot of the packages into the core project. It has become quite. One thing is it's quite difficult to maintain all the repos because they have different build setups, linting, and all this stuff. But also for the users, like we created the CLI because we wanted it to be like, okay, just install it and get running. And one part of that is, of course, the boilerplate, which we still need a concept for. But we also wanted to do it because there were so many different packages. But now that is heavily reduced. And it also makes the code cleaner, especially related to the dev tools and the router. But everything has this structure now. Everything is like, it's class-based. Even though I would never write a class in an application, it's really nice for APIs, because you define methods, and that is what an API is. But in an application, it's more about flow. It's not about calling methods, which is why I don't like classes in applications. Anyways, so every class and method has like a description of what it's supposed to do, and they are as short as possible. And also the files are really short. So you have like computed, there shouldn't be more than 200 lines of code. And then we have this dependency store, which I'm super happy with, which handles all this depending on state, which both React and also the computed use. So it's like a generic way to handle entities related to path dependencies, kind of. Yeah, it doesn't matter. I can look into it. But yeah, the code is super simple now, so it should be a lot easier to contribute to the project. So super happy about that.
Yeah, I took a peek through, and the difference is pretty amazing.
Yeah, but that's because the previous was really bad.
I remember it. Yeah, I looked through it. I was like, let me see what's actually going on, And then I think I opened up what was it?
Yeah.
Create static tree or execute tree?
Yeah.
Something like that. I think I looked in a file and it was like 350. It was like a 350 line method, and I just quietly closed my computer and went to sleep for an hour.
Yeah, I've even had that experience going back to the code. But yeah, most of the reason the code is shorter now is because it's just a wrapper around function tree. But even function tree is a lot less code than it used to be. So yeah, and this is what it's all about. Very few concepts we know today is just take Flux, for example, where Redux has kind of become the official Flux implementation. It takes a lot of iterations, mostly because it starts out by fixing one scenario. I had my vision of this. I need to fix my own problem. And then suddenly people have similar problems, and that's where the iterations start. It's okay, it can't fix my problem, but if you can adjust just this part of the API or implement this, then it will be awesome. And then we constantly have to balance it out. Sometimes we take a step too far, and yeah.
I think that's the only way to do it, though, to have a problem that you want to solve and start there.
Yeah, and we can proudly say that Cerebral is actually based on solving real application issues. We're working with applications every day, and complex applications. I hope this demo of our project show that that's real application complexity. It's not about changing freaking counters.
Preach it.
Preach it. Oh yeah. But yeah, I don't know. Do you guys have anything you want to talk about?
Awesome work, I think, Christian. I looked through the function tree and Cerebral too, and it's amazing.
Yeah, I'm really
looking. So do you sleep?
Yeah, it's actually super weird. We talked about the next version of Cerebral, and kind of shoving it in front of me, that's for later. But then it's kind of weird. Suddenly happens. It's like a typical shower thought, but it's a big one. And then you sit down, and suddenly everything just fits. And function tree was the thing. Okay, what if Cerebral is a wrapper around function tree? And then it kind of everything kind of came around through that. And that is also when you know you made a good decision, is that you don't get blocked when you start implementing. Everything kind of fits in its place, and it cleans up, and even the debugger became a lot simpler and optimized because of that decision.
Yeah, it's really cool how everything just got clearer. That's when you know you're on to like the right abstraction, when everything gets clear. All the concepts are more concrete, like services go away, you know, things like that. It's really cool.
And just the small demo on the first video, like you have this React application which has internal state, and it has a method for changing its internal state. And then just what happens when you scale this? How do you share that state? You have to pass it as props, and you get like intermediate components passing props for other components. And if you want to change that state, you have to pass the method. You have to bind the method at the top level and pass it as
pass your callbacks around.
Yeah. And then just with like the new simple syntax, just nail it. Like, this is the state, this is the signal, and now you can add as many components as you want. You can connect that state and that signal to any of those components. So yeah, it's super awesome.
Yeah.
Yeah, I'm getting tired. I'm just super excited.
Yeah,
it's probably a mix of all this baby stuff and and Cerebral.
your two babies.
Yeah, my two babies. Oh,
I'm very excited too.
Yeah. We should I don't know, can I play mute? No, I don't think I can play. I got a baby song from Brian with beatboxing. It's super awesome. We have to share it.
Yeah, that's for your ears only.
Oh, okay, yeah.
No, it's okay. You can share it.
I'll share it on Kittens.
Yeah. I gotta run though, guys.
Yeah.
Great work.
Thanks for the walkthrough, Christian. It was awesome.
Yeah.
Great. Talk to you later.
Okay, see you guys.
Yeah.
Bye-bye.
Yeah.